Hello everyone. Today we are going to discuss about the Capstone project 10, that is e-commerce customer support analysis, which is a EDI classification and front-end based analysis. And this is my project summary for what we have for the data set. That is a big data set of 85,000 interactions for all the inbound, outbound email categories of customer analysis reports and my GitHub repo. This comes to the main problem that we want to discuss is about these to protect the CSAT score, that is the customer satisfaction score, that is whether they're satisfied or dissatisfied or neutral based on the interaction from the metadata that we have and based on the agent attributes that we are going to find out whether we have as satisfied or dissatisfied results. Coming to the libraries, we are importing standard libraries and NLTK libraries and few ML libraries that to process and find out model machine learning model analysis and also deep learning like few TensorFlow, Keras, etc. And yeah, as you can see that we have the TensorFlow version that is 2.21 that is available for now. And my data set, this comes my data set here, the first 5 rows of data set with 85,000 rows. And coming to information, most of the rows are almost filled and very few of them are having uh, empty values. Let's see if there are any duplicate values and null values. We can say there are no duplicate values, but we can see the missing count of, so there are null values available in the dataset columns, as you can see here. As you can see, the missing percentage of columns that are there. That is what I mentioned here. And my columns list, the all the columns list, the 20 columns, I suppose. Yeah, 20 columns that are available. And the information, the description about them, and all the information about the 20 columns, checking whether if there are any unique values in the dataset. But yeah, there are. Coming to data wrangling, what I've done in the data wrangling is that I've passed datetime columns and derived response times in minutes rather than seconds, and extracted hour of day and day of week for analysis for EDA, and flagged rows that are where remarks are available, whether that is available or not. I flag them as 0 and 1. That is what I've mentioned here as well, all the manipulations here. Coming to the first chart, that is the CSAT score distribution, whether we can see that is a satisfied or dissatisfied in the percentage ratio. We have 82.5% as satisfied and 17.5% as dissatisfied. And how many, I wanted to show the count of the CSAT score as well, as we can see here. Coming to the second chart, that is contact channel distribution, whether how the satisfaction report is measured, whether that is inbound or outbound or email through. The third chart is issue category distribution. As you can see that the returns are leading with through the horizontal bar chart. And the next chart comes the agent tenure bucket. How many people are, what is the status of the agent, whether there are more than 90 days or 61 to 90 days, 31 to 60 days, 0 to 30 days, or on-job training. And the fifth chart comes the agent shift distribution with how many calls people are attending for the uh, getting feedback. Most of the calls are being attended in the mornings and evenings. And the next chart is the CSAT distribution by channel. As you can see that in every outbound channel, number of stars given rating as 5 is more. In the seventh chart, as you can see, that I wanted to show about the satisfaction dissatisfaction by the tenure bucket, as we have 5 tenure buckets. For most of them, like 80 is the average for satisfied score. And coming to the chart 8, that is, I wanted to show you about the satisfaction rate by issued category with the median of 80 percentage. That is a threshold. And coming to chart 9, that is the satisfaction rate by agent shift. As you can see that in the split rating, that is any two combined. As you can see, that has the highest rating compared to other ones. In the chart 10 that I wanted to show you about the response time in minutes for the CSAT score, for how much time people are talking to the customers. As you can see here, the response time in minutes, giving back responses, giving back feedback is about for 20 minutes and gradually reducing for 5 stars. In the chart 11, that is the item price distribution by CSAT score. As you can see that the density is more at price 0 to 5,000 only. Coming to the chart 12, that is the contact volume satisfaction rate by the hour of the day. As you can see, the hour of the days are mentioned in the x-axis and the contact volume and the satisfaction percentage are given in the dual y-axis. Coming to chart 13, that is satisfaction rate by the product category. Most of the satisfaction is available for the affiliates, and next comes the lifestyle. Next comes the chart 14, that is correlation heat map. As you can see here, the CSAT binary score for the CSAT that is highest. And next comes the connecting handle time with the item price with 0.65. And next is the chart 15, that is a pair plot for the number of key features. Now comes the hypothesis statements. For three hypothesis statements that I wanted to find. The first one is the proportional satisfied customers are in the same day tenure for the more than 90 day tenure and on-job training, but the hypothesis was proved wrong with the p-value. For the first analysis, I used chi-square test of independence, but I did not find the hypothesis was rejected. And second statement I have, that is the whether the mean response time is different for the or same for the CSAT score satisfaction and dissatisfaction. For this, I performed Man-Whitney U test, and for this also I've got rejected results. And coming to the hypothesis 3. In the hypothesis 3, I found out that the CSAT score distribution is independent of contact channel, that is inbound, outbound, or email through. But that is rejected as well because of the p-value. We don't have enough p-value to support the statement. So that is rejected as well. For this, I used chi-square test of independence. And coming to the feature engineering and data pre-processing, these are the standard pre-processing techniques for because that most of the data is uh, most of the columns have textual data and uh, numerical data as well. As you can see, handling outliers and categorical encoding as well, textual pre-processing and lower casing done to for the analysis, for the neater analysis to be possible, and punctuations if there are any there that I have removed them, and any URLs that are available, all the URLs in the data set, and remove stop words also, and rephrasing, tokenization using lemmaization technique here, text normalization lemmaization techniques. And yeah, feature manipulation as well. As you can see, after me feature manipulation, as you can see for the logarithmic values for information about non-parametric filters, data transformation, log1p with data transformation values, data scaling, dimensionality reduction. We don't need dimensional reductions for the very small data set. So I did not do any dimensionality reduction techniques. Data splitting, I used 0.2, 82, 80-20 testing with 80% of trained data is having 68,700 rows, and for the 20% we have 17,000 for testing our data. And also we can see that I also wanted to see the class balance, how many truth values are there and how many false values are there. So we got equal ratio. So that is a perfect split for 80-20 percentage data. And next comes the ML model, machine learning model implementation. For the first model, I used XGBoost technique. As you can see here, the first method is XGBoost technique, and we got accuracy 0.83 and 0.76. And I'll show you the chart also for this one. Yeah, this is the results, 0.83 and 0.76 for the cross validation. After cross validation, have hyperparametrics. Second comes the ML model too, that is the artificial model, neural network model using TensorFlow and Keras. For that, for the second model, we built the model and we used the standard two hidden layer model, ANN model. As you can see here, I used 50 epochs, but I didn't want overfitting, so I stopped the model whenever the model is feeling that the data is enough for our exact model building. So I stopped at epoch 44, and after training, as you can see here, the train loss and the loss values are symmetrical. And after evaluating the model, as you can see here, this is the confusion matrix. As you can see here, the satisfied values and dissatisfied values are more compared to the uh, false values. And the ROC AUC model value of AUC score is 0.75, that is 75% of truth value. And after tuning, we got 68% of accuracy. And third model is deep regularized ANN, and that is also using TensorFlow and Keras. And here also we used 60 epochs, but I didn't want to overfit my data. So whenever I found out that my data is fitting exactly to the required results, I stopped using at the epoch. So here I stopped it at epoch number 39. So uh, after training my model, as you can see here, this is the loss curve of deep ANN model using TensorFlow and Keras. You can see the the training loss curve and the valuation loss curve here, and the accuracy is 68%. After cross validation, also we'll be getting 68% as uh, the accuracy. And after that, I measured to choose which one I wanted to choose as my final output model, whether XGBoost or ANN or deep ANN models. So after checking that, I found out that my XGBoost is giving accuracy as higher accuracy model compared to all the other three models in accuracy and ROC AUC as well. I've been getting XGBoost as my highest model. So uh, in the feature importance as well for the I used that. So I when I wanted to save my model and show my front end, I used my CSAT prediction model for XGBoost model to show my updated front end. And then this is my example for testing whether my confidence model is running exactly or not. I checked the sanity sample check using five samples and the conclusion as well. This is the product that I have explained. And next, coming to the uh, anti-gravity, as you can see here, my Streamlit is my Streamlit front end, and that is running as well in the front end right now in the terminal. In the terminal, I've been using Streamlit Run in my application using my CSAT prediction model package libraries and mapping libraries and label encoders for the model and requirements txt is where I have my all the requirements for the model that I wanted to upload in GitHub, and if anyone wants to use it. And this is my Streamlit app for my front end for this model. This is the whole entire Streamlit application front end, and I will show my front end application as well. The CSAT application. This is the front end model that I've been built based on the results I've been getting in the IPYNV file for the three ML models. This is we can change here the values and we can predict our CSAT customer satisfaction value. So yeah, as you can see here, few whether the channel is email, the agent name, response time, all the categories that are there in the data set, we can update here and we can predict how much can the how much would the customer satisfaction result be. uh, would they give us a feedback. Okay, so this is what we can see. We can predict here and we can see that the score is dissatisfied for this particular scenario. And I have also wanted to show what is the optimal strategy for my to get maximum CSAT value, customer satisfaction value of near perfect score, whether the customer is satisfied or not. And I also put a separate section for instant optimization score, that is optimal parameters to get the near perfect score. As we can calculate it and we can see that the prediction score is satisfied for this particular scenario, and then the customer satisfaction output in the feedback would be satisfied. In the predictor model we got for this, as we can change the value for 100, and let us say the issue hour is 1 in the midnight, and the tenure bucket is more than 90 days. And we can check some other person. Let it be from letter B. Okay, Bob Keith. And let it be onboarding related or cancellation stuff, and we can predict the CSAT score. That is 1.2 now. The AI confidence level is also 5.8. So if the confidence level of the model is higher, then then the prediction score will be higher. Whether the as you can see here in the satisfaction score, see this is the confidence level that the model would be predicting. If it is more than 80 percentage or 85 percentage, then it would be giving as the result as satisfied. There are three categories that I want to show. One is satisfied, dissatisfied, and one is neutral. Whether the CSAT prediction score is from 0 to 3, we'll be getting as dissatisfied. 3 to 4 is neutral, and 4 to 5 is satisfied. Is what I wanted to show. This is my front end and analysis for my e-commerce satisfaction as well. Thank you.